Once a year, in the brutal cold of northern China, a vast workforce comes together to create an entire city made purely from blocks of ice. So, how do they actually make it happen? The secret lies in an enormous logistical effort where 10,000 workers collaborate to raise a gigantic city, one that even surpasses the size of Vatican City in only 30 days. To achieve this, they begin a year in advance, cutting and storing thousands of tons of ice from a frozen river, carefully preserving it through the scorching summer months without letting it melt. This monumental project requires more than $500 million, yet it exists for just 60 days before disappearing completely. Now, let's explore how this breathtaking engineering wonder rises from nothing. Creating the largest ice park on Earth isn't just construction. It's a carefully timed battle with nature that begins months before winter truly takes hold. While the build officially starts in November, the real work has already been underway for nearly a year. As early as January, when the river is at its coldest, massive blocks of ice are cut, transported, and preserved through the long, unforgiving summer. All of this effort leads to one crucial moment. When winter returns and the river freezes once more, the foundation can be deployed instantly, turning months of preparation into a city of ice almost overnight. Powered circular saws slice across the frozen surface, etching out long, perfectly aligned grooves that stretch for miles, forming a vast, precise grid beneath the ice. But once the machines finish their part, the real test begins. Human strength steps in. Workers grip heavy steel bars with pointed tips, positioning them along the cut lines, then strike in unison to break the ice apart. That perfect synchronization is critical. Every strike must land at the exact same moment to split the ice cleanly and evenly. Because in this delicate process, even the slightest mistiming can ruin everything, shattering the block into useless fragments. To meet the deadline, a workforce of 10,000 people must extract an astonishing 7 million cubic feet of ice in just 3 weeks. That volume is so immense, it's like packing 80 Olympic-sized swimming pools solid with frozen blocks. A mission on this scale can only succeed under rare and perfectly aligned natural conditions. As freezing air locks the river's surface in ice, the water beneath continues to flow calmly and continuously. This slow-moving current becomes a natural purification system, sweeping away bubbles, minerals, and impurities during the freezing process. What remains is ice of remarkable quality, up to 99% pure water, incredibly durable, crystal clear, and strong enough to support towering structures, rising as high as 14 stories. Each massive ice block can weigh as much as 1,000 pounds, turning every movement into a challenge of both strength and strategy. To transport them across the frozen river, workers carve out long, narrow water channels, transforming the surface into a natural flow system. Thanks to the buoyancy of ice, these half-ton blocks can be guided effortlessly, drifting toward the shore with just a gentle push. Once they reach the end of the channel, mechanical ramps take over, lifting the blocks out of the water. Beneath these ramps, rotating chains fitted with steel hooks latch onto the ice from below, securing each block in place. This ensures every piece remains stable and controlled as it transitions from river to land. In these brutal conditions, the water never truly stays liquid. It's constantly on the verge of freezing again. Every second becomes a battle against time. If even a single block slows down for just a few minutes, it can freeze solid almost instantly, locking itself back into the river and bringing the entire operation to a halt. Once the ice is lifted from the water, the entire operation enters a new phase. Large-scale transportation takes over. Heavy machinery like forklifts and transport trucks move in sync, loading and hauling the massive blocks directly across the frozen surface. The entire system operates right on the river itself, turning it into a giant open-air factory floor, the only space vast and flat enough to sustain such intense movement and volume. The loaded trucks roll out toward a designated storage zone set along the outer edge of the park. This staging area sits only a short distance away, just a few hundred meters from the river itself. Over the course of the season, the convoy will complete more than 1,500 trips to relocate the entire ice supply, traveling a combined distance of over 4,500 kilometers. That's roughly the same as traveling from Boston to San Francisco, crossing the entire width of the United States in a single journey. At the storage site, massive excavators begin the next phase, carefully stocking the ice blocks into towering formations that resemble frozen mountains. Each of these enormous piles can hold up to 20,000 blocks, with a total weight exceeding 9,000 tons. But the real challenge isn't just stacking them, it's preservation. These frozen giants must endure nearly an entire year in storage before they are finally brought back to life in the construction of the city. To prevent the ice from slowly shrinking or melting away, the team turns to a clever principle of physics known as the cold sink effect. Because cold air is denser than warm air, it naturally sinks downward, becoming trapped in the gaps between the stacked blocks. Deep inside the pile, temperatures drop so low that the ice essentially creates its own cooling system, staying frozen solid even through the peak of summer. But temperature control alone isn't enough. Moisture management is just as critical. That's why the ground beneath is layered with gravel, allowing water to drain away instead of collecting underneath. If even a small amount of water is trapped at the base, it can act like a heat reservoir, gradually warming the ice and weakening the entire structure from below. Once a towering ice mound is fully assembled, the next priority is preservation, sealing it off from the outside world. Workers begin by covering the entire structure with thick layers of straw. Each strand of straw functions like a miniature insulating tube, quietly holding pockets of air within. And since trapped air transfers heat very poorly, these layers become a powerful thermal barrier. Millions of these tiny air pockets work together, slowing down the relentless heat of summer. It's the same concept behind how thick winter clothing shields the body from the cold. But insulation alone isn't enough, so an additional protective layer is added on top. Large sheets of white foam and massive tarps are spread across the surface. Much like wearing light-colored clothing under harsh sunlight, these bright surfaces reflect most of the solar energy away, preventing heat from ever reaching the ice beneath. This system is so effective that even after a year, the ice block retains more than 90% of its original volume. 10 months have slipped by since the ice was first harvested. Now it's November, and the Earth has frozen solid once more. With winter fully returned, the team moves under an unforgiving schedule. They have just 30 days to construct an entire city spanning over 250 acres. That's the equivalent of nearly 190 football fields. A project of this magnitude leaves no room for delay. Every second must be used with precision. Because the central tower is designed to rise over 108 feet, ice alone simply isn't enough to support it. To handle such extreme height and weight, engineers begin by erecting a massive internal steel framework. This framework functions like a backbone, giving the tower the strength needed to carry millions of pounds of ice. Without this hidden support, the structure could sway under strong winds or even collapse under its own weight. Most people assume steel is nearly indestructible, but at -20 degrees Fahrenheit, ordinary metal behaves very differently. It loses its flexibility and becomes brittle, almost like glass. Using standard construction steel in these conditions could put the entire tower at risk. To overcome this, the team turns to specialized low-temperature steel, engineered to remain stable in extreme cold. This alloy is enhanced with elements like nickel and manganese, giving it unique resilience. These additions prevent the metal's internal structure from locking rigidly when temperatures plunge. As a result, the steel stays tough yet slightly flexible, able to bend without breaking. Welding this material, however, introduces another level of complexity. The torch burns at thousands of degrees, while the surrounding air remains far below freezing. Such an extreme temperature contrast would cause ordinary steel to crack instantly. But this specialized alloy is built to withstand thermal shock, keeping every joint secure and intact. Inside, the steel frame is hollow, allowing miles of electrical wiring to run through and illuminate the tower. The crew has only a few days to raise this entire structure into position. They assemble large sections on the ground before carefully lifting them into place. Even the slightest misalignment at the base could amplify at the top, causing the tower to lean dangerously. As the tower climbs skyward, another team gets to work across the park, building up a massive hill of packed earth. This structure will become the foundation for the Grand Slide, the park's main attraction. Their objective is simple but ambitious: carve out long, winding tracks where visitors can race down on sleds. The entire city depends on one critical system, the electrical network. In total, it spans over 150 kilometers of cabling. That's equivalent to stacking the height of the Eiffel Tower more than 450 times. But the greatest threat isn't the cold, it's hidden moisture caused by heat. Even in freezing conditions, thousands of LED lights generate enough warmth to slowly melt surrounding ice. If that moisture reaches an electrical joint, it can trigger an arc flash, an explosive discharge of energy. One such event could shut down power across the entire park in an instant. To eliminate this risk, every connection is sealed in 3 layers of waterproof protection. As the sun dips below the horizon, the steel framework finally stands complete. Now, the team prepares for the next phase, bringing in the first massive ice blocks to cloak the structure. After lying dormant for over 10 months, the ice is about to reveal how well it endured the summer heat. Back at the storage yard, workers begin stripping away the protective layers. From this moment on, every second counts. It's a race against both time and rising temperature. If the insulation is removed too fast, the sudden temperature shift can fracture the ice. Exposure to direct sunlight can also strip away its crystal clarity. After months in storage, many blocks have fused together into larger masses. The imperfect, uneven pieces are set aside for internal construction. Only the most flawless blocks are selected for the outer surface, where appearance matters most. The storage yard has transformed into a high-intensity logistics hub, with trucks constantly arriving and unloading fresh ice blocks. Before anything is used, workers carefully inspect and sort each block based on its quality. The entire site runs with machine-like precision, 10,000 workers moving in perfect coordination like a living industrial system. Massive ice blocks may look solid, but during transport, they're incredibly dangerous. Each piece is heavy, smooth, and unpredictable, turning every movement into a potential hazard. Stacking them is even riskier. One slight misalignment and the entire load can shift without warning. With surfaces as slick as glass, a single slip can send tons of ice crashing down in seconds. In this environment, precision isn't optional. It's the only thing keeping everyone safe. And it's not just the ice. The weather can turn against them in an instant. Without warning, powerful winds sweep through the site, forcing all work at height to stop immediately. Tower cranes are shut down to avoid catastrophic accidents. From that moment, the operation shifts to ground level, focusing on safer tasks like building the massive ice slides. The Grand Ice Slide isn't just a ride, it's the heartbeat of the entire park. Stretching over half a kilometer, its scale is hard to grasp, long enough to rival 5 football fields laid end to end. Built with 24 parallel lanes in just over 2 weeks, it's a masterpiece of speed and coordination. The design is engineered for pure adrenaline. A steep initial drop builds momentum, a sweeping curve amplifies the thrill, and a long, controlled runout ensures a safe finish. Every inch of the surface is precision cut, forming structured grooves that keep sleds locked on course at high speed. The ride itself lasts just 40 seconds, but the demand is relentless. Visitors wait for hours, sometimes up to 7 for a single run down the ice. Behind the scenes, it all begins with a massive engineered hill, built, reinforced, and shaped before a single layer of ice is applied. What makes it remarkable is the contrast, one of the fastest builds in the park, yet one of the most complex to execute. It's where construction, physics, and human experience collide, under extreme conditions where timing is everything. On the ground, another team carefully constructs the Ice Tulu, a circular structure inspired by traditional Chinese architecture. Its curved design isn't just aesthetic, it's structural. Each block leans on the next, distributing the load evenly across the entire ring. But this balance is fragile. If even one block is misplaced, the entire structure weakens and could collapse from within. By the next day, as the winds finally die down, construction surges back to life at full pace. Lost time puts pressure on the entire operation, forcing crews to accelerate every step. From that moment on, every second matters in the race to stay on schedule. Workers begin by placing the very first layer of ice at the base of the central tower. This foundation has to be perfect because everything above depends on it. Even the smallest crack could compromise the entire structure. Meanwhile, snow cannons blast out huge volumes of artificial snow across the site. This layer becomes the ground surface visitors walk on throughout the park. Engineers shape it with precise patterns to spread weight evenly and prevent sinking. At the same time, lighting systems are installed deep within the structure before the ice seals them in. Once frozen in place, there's no way to access or repair them. Thanks to the clarity of pure ice, the lights can shine through brilliantly, illuminating the entire structure from within. A sudden spike in temperature begins to soften the ice, turning solid surfaces unpredictable. Work on the towers is stopped immediately to avoid structural risk. Cranes and snowmaking machines are shut down as a precaution against potential collapse. With conditions no longer safe above ground, crews quickly shift their focus. They move to ground-level tasks, finishing insulated domes designed for visitors. These heated shelters will become essential once the park opens, offering warmth in the freezing environment. Once the river freezes solid again, the operation shifts to using freshly cut ice instead of stored reserves. These new blocks are cleaner, thinner, and far easier to shape and position. With better material in hand, construction accelerates at a much faster pace. This city isn't just built from ice, it's built on timing. Stored ice gives them a head start, but it's only temporary. When fresh ice arrives, everything changes. Cleaner, easier to shape, faster to build with, it becomes the key to accelerating progress. In the end, stored ice starts the race, but fresh ice is what gets them across the finish line. While the city continues to rise on solid ground, a completely different challenge unfolds out on the Sona River. Here, engineers construct a 1/6 scale replica of the Liaoning aircraft carrier, not on land, but on a floating industrial barge. Building on water introduces constant instability. If weight shifts unevenly, the entire platform can tilt, threatening to send tons of ice sliding into the river. To counter this, every move must be mirrored. For every block placed on one side, another must match it on the opposite side, keeping the structure perfectly balanced. The replica stretches over 230 feet and requires more than 353,000 cubic feet of ice. Workers carve the hull by hand, using scrapers and saws to shape frozen blocks into surfaces that resemble steel plating. Because it sits directly above the damp river, the ice bonds faster than in the main park. At night, powerful internal LEDs bring the structure to life. A cold blue glow cuts through the darkness, casting a sharp silhouette across the open water, visible from miles away. But long before towering ice cities and massive sculptures, it all began with something much simpler. During the Qing dynasty, local fishermen faced a constant problem: the relentless Siberian winds. Their lanterns would be blown out almost instantly. So they found a solution: freezing river water into a hollow shell. A candle placed inside would stay protected from the wind, burning steadily for hours. Decades later, that simple idea evolved into something far greater. In 1963, the city transformed it into the first official ice lantern exhibition. Using only basic tools, artists carved blocks of river ice into animals, flowers, and miniature buildings. Lights were placed inside, turning solid ice into glowing sculptures. By 2001, the event merged with a major winter festival and evolved into the world-famous Harbin International Ice and Snow Sculpture Festival. From a single flame protected by ice to an entire city built from it. As the ice towers reach their final height, attention shifts to the colossal snow structures that complete the park. These are built last for a reason. Snow weathers far faster than ice. Carved too early, and wind and sunlight would erase the details before opening day. The process begins with a single massive block. Workers erect large wooden molds, then blast in artificial snow, compacting it layer by layer. Under intense pressure, the snow crystals fuse together, forming a dense structure almost as solid as stone. To sculpt something this large, artists always work from the top down. As they carve, excess snow falls away naturally. By finishing the highest point first, they prevent debris from damaging the details below. At the center of it all stands the Great Snow Buddha, rising nearly 100 feet tall. It serves as the spiritual heart of the park, symbolizing peace and blessing. A team of 30 artists works in perfect sync to maintain its precise proportions. The early stages are all about removing mass. Crews use chainsaws and shovels to carve out the rough shape. But unlike ice, snow offers no second chances. Once material is cut away, it cannot be restored. As the sculpture takes form, tools become smaller and every movement more precise. By sunset, the transformation is complete. Floodlights wash the Buddha in pure white light, casting deep shadows that reveal every contour. In that moment, the snow no longer looks like snow. It resembles polished marble, carved from light itself. The ultimate centerpiece of the city is its main tower, the tallest and most intricate structure in all of Harbin. As it nears completion, brutal cold and intensifying winds turn the final Marachel into a high-risk operation. For both masons and crane operators, every lift becomes a race against the elements. What gives the tower its strength is a unique hybrid design. As temperatures drop, the ice begins to contract, tightening around the internal steel frame. This creates a powerful thermal bond, locking both materials into a single, rigid structure. Thanks to this, the 141-foot spire can withstand powerful wind gusts without losing stability. Once the final block is set and the scaffolding is removed, the transformation is complete. Rising 14 stories high, the tower becomes a glowing beacon at the heart of a 13 million square foot frozen city. Even in brutal sub-zero conditions, the sun remains a silent threat. Its heat can gently soften the ice surface, creating tiny fractures and turning crystal-clear blocks dull and rough. To fight this, workers rely on a surprisingly simple solution: slush. By blending crushed ice with a small amount of water, they create a dense, icy paste that works like natural mortar. This mixture is carefully applied to cracks and sun-damaged areas. In the freezing air, it solidifies almost instantly, sealing gaps and restoring the structure's strength. This constant maintenance becomes a daily ritual, preserving both the strength of the structures and the sharpness of every carved detail. 10,000 workers, 14 million cubic feet of ice and snow. Every column, every arch, every towering spire is carved from blocks cut straight out of the frozen Song River, shaped in temperatures that plunge to -20 degrees Fahrenheit. This is engineering at its most intense, compressed into a single place, a single moment in time. From the 141-foot central tower to the nearly 100-foot Great Snow Buddha, the entire city stands as a structural marvel. A fusion of steel and ice where gravity is held in check by the raw force of the cold. After 22 days of relentless construction, the machines finally fall silent. Before the gates open to millions of visitors, the city pauses, frozen in a moment of perfect stillness. This is not a permanent city. It is a temporary masterpiece, engineered to exist for just 60 days. Born from the river, it rises in brilliance, only to return to water when spring arrives. The 26th edition of the Harbin International Ice and Snow Sculpture Festival is ready to begin. Harbin Ice and Snow World is more than a display. It's a living, breathing city of ice. From morning to midnight, it pulses with energy, thrill rides, glowing skylines, and performances that bring the frozen landscape to life. For just 60 days, millions arrive to witness it, racing down icy slopes, drifting above it in silence, and watching art carved in real time. But this brilliance was never meant to last. As spring approaches, the glow fades, the towers fall silent, the sculptures dissolve, and 14 million cubic feet of ice returns to the river it came from. No ruins, no remains, just water and memory. Yet, even as it disappears, the story isn't over, because deep in the shadows, the next city is already waiting, frozen, silent, ready, waiting for winter to rise again.